Hello, and welcome to Backer Breaks It Down. In today's episode, we're going to look at applications with oblique triangles. So, what does that mean? It means that we're going to use either the law of sines or the law of cosines to solve some word problems. Okay, so the law of sines, remember the law of sines we can totally use if we have the buddy system. So, what that means is if we have like an angle and we also know the side opposite the angle, we can use the law of sines. And if we don't have the buddy system, then we have to use the law of cosines. The problem you see here basically wants to know how far is the island from the beach. And by the end of this lesson, you'll be able to answer such a question. Okay, so let's check out some applications with oblique triangles. So in this problem here, it says in order to determine the distance between 2 points, A and B, on opposite sides of a lake, a surveyor chooses a point C that is 900 feet from A and 225 feet from B as shown. If the measure of the angle at C is 70 degrees, find the distance between A and B to the nearest foot. So I want to ultimately find this distance here, okay? So think about what information we're given. Do we have the buddy system? That's correct. We do not have the buddy system. I don't know angle A, however, I do know side A. I don't know angle B, however, I do know side B. And I know the measure of angle C, but I don't know the measure of side C, which is what we're trying to find. So I don't have the ability to use the law of sines. It's just not going to work out here. And I'm finding missing sides, so I'm not going to use the angle formula for law of cosines. So I'm going to use a side formula for the law of cosines. Okay. Now, if it helps, because that formula written at the top of my screen is written for side A, well, we could just tweak this and we can make this angle A. Thus, this is side A. I'll make this C, and then this one side C. And so now it's perfect, right? So remember, law of cosines is simply a formula. So we're going to make that substitution, calculate, find our solution. And that's what I did here. So notice that I substituted our given values into the law of cosines formula. I calculated that, and then I took the square root. So the distance between A and B to the nearest foot is 850 feet. So let's try another one. Two markers, A and B, on the same side of a canyon rim are 80 feet apart. A hiker is located across the rim at point C. So our hiker is here at point C. A surveyor determines that the measure of angle BAC is 70 degrees and the measure of ABC is 65 degrees. Find the distance to the nearest foot between the hiker and point A. So this is what we want to find. So what are you thinking here? If it helps, I will draw out this triangle. Oh, so when I was drawing it, you noticed that we know two of the three angle measures. So that means it's very easy for us to find the third one since all three angles add up to be 180, right? So this angle right here is 45. So what are you thinking when it comes to our method? Yeah, we totally have the buddy system right here with the angle and its opposite side. So we can totally use the law of sines to find our missing segment, right? And so that's what I did. So I said the sine of 45 degrees over 80 is equal to the sine of 65 degrees over x. I cross multiplied and divided and calculated, and I got that the distance was 103 feet. Great. One more. A hot air balloon is seen over Tucson, Arizona, simultaneously between two observers at point A and point B. They are 1.75 miles apart. The angles of elevation are shown. How high above the ground is the balloon? Okay, so take a look at the current diagram. Anything coming to mind? Yeah, totally. This angle right here, we technically know the measure of. It wasn't given to us directly, but we can easily find it since all three angles add up to be 180. So then that angle up there would be 110. Now what? Yeah, so now we have that like angle side pair with this 110 and 1.75 mile side. So we can totally use law of sines. Like that is definitely something available to us because I have the buddy system and this is that ratio. So what can we use the law of sines to find? Like, will it find how high above the ground the balloon is? Because let me show you what that is. Like right here, that's the height. That's what we need to find. Okay, and is that height a side of our triangle with the 110-degree angle? You're right, it's not. Okay, so then clearly the law of sines we can't use to directly find the height, but we can use it to find something else, right? So I can use the law of sines to find either observer A's distance to the balloon, or I can use it to find observer B's distance. Okay, it doesn't matter which one you choose to work with, like ultimately we'll all have the same final answer. Okay, but we can use the law of sines to find either the side I'm calling X or the side I'm calling Y. Okay, and so realize like once we know the measure of one of those sides, we will be able to find the height the balloon is above the ground using some right triangle trick. So check it out. Okay. Um, so like remember we determined that this was 110 degrees and that the law of sines can be used to find one of those missing sides. So it looks like I found this distance. I called it Y on the previous page. Okay, so I'm calling it A here. Oh my goodness. Okay, but I can use the law of sines to find side Y. Okay, and so I did that and I got like 1.014. So that's like this one right here. So then I have this right triangle here and I'm curious about the height of it. I know the hypotenuse is 1.014. So I can use a right triangle trig ratio to find the height. So I'm saying sine of 37 degrees is equal to h over 1.014, h being the height, 1.014 being the hypotenuse. So I simply cross multiply, calculate, I get that the height is 0.61 miles. Okay, so that's how high the balloon is flying above Tucson. And so this was like how we opened it, this whole lesson. So like how far is the island from the beach? And so you can do such a problem now using what we did in the hot air balloon problem. So use the law of sines to find one of these two missing sides and then use a regular right triangle trig ratio to find the height or the distance the island is from the beach. Try it. And that's how Backer breaks it down.